Hey there, fifth graders. We started something the other day, and I want to try it again here today. So we started looking a little bit at the probability of different cards you'd pick when we play Card Sharks in class, and then to try to look at see these and see like, okay, well, what's happening? So I put together kind of an approximate chart, and I want to say approximate because depending on the cards that you already picked, it's going to change these percentages, but just a little bit. So for example, in this case, a six. If you picked a six, if you look at this chart, it's about a 62% chance that the card is going to be higher, 31% chance that it'll be lower, and 8% chance that it'll be another six. So we can use that to our advantage. So what this says is probability says is that you should probably say higher. And in theory, if the probability works out, if we played this game 100 times, which you can't because there's only 52 cards, but if we played it 100 times, you should get higher 62, you should get lower 31, and you should get another 6 8 times. Now that's assuming that we pick a 6 and we shuffle the deck every time and we pull them back in. So there's a whole lot of things to just assume. It also assumes you have the time to play this 100 times. So instead, what I want to try to do is show you a way that you can try this game, see it. And again, knowing that these are approximations, the numbers are going to change every time you pick a card, but to take a look at this and actually experiment with this in a way that has you not do it 100 times. So here's a way you could do it here. Instead of doing 100 tests, and I'm going to try to do this here with my touchpad here, you can actually do it with 10. So, and this will just help us approximate. So let's say we use the six. Okay, we're going to use the six. I'm going to pull this six of diamonds out of the deck. We're going to put this over here and get it out of the way. According to the chart, what that tells us is that 62% of the time we should pull up, and I'll shuffle these, we should pull up a number that's higher than a six. 31% of the time it should be lower, and 8% of the time it should be the same. So since we're only going to do 10 times and we're not going to do six, we're going to change this a little bit. So what that means is instead of 62 times that it should go higher, it actually means it's going to be closer to six. And I'm just going to round down because we're only going to play at 10. Three times it should be lower. And then this has to add up to 10. So if we round 8% up to like one whole, we should get one time that it's a six. So I'm going to go ahead and I'll start pulling out cards. And what we'll do is we'll just keep track of this for 10 times and we'll see how many times it's higher, how many times it's lower. Well, it doesn't like the touchpad, and how many times it's the same. Okay, so we'll go ahead and do this. As far as rules go, once I pull a card out, we'll leave it out. I won't reshuffle them. So that, again, fudges the numbers a little bit, but we just want to see if this works. So we're going to use six as our guide here. So here we go. Here's the first one. And I'm just going to take them off the top here as we go. So the first one is lower. Now we're going to predict that we're going to get three cards that are lower. Let's see if that actually works. So that's one of them. I'll put a little mark next to lower. Okay, here comes the next one. That's higher. Okay, and we're going to predict that we're going to get six that'll be higher. Okay, here comes the next one. 10. So that is definitely higher. All right, here comes the next one. Ace, definitely higher. Here comes the next one. 2, definitely lower. So probability says we should only get one more card that's lower than that. Probability means that's what will probably happen. It doesn't mean that's what's definitely going to happen, but it should be pretty close. Here we go. We've got a 5. That's lower. So probability says we shouldn't have any cards lower anymore. Here we go. Higher. So we're up to 7. So we got 3 more to go. There's a 10. That's higher. So there's 5. So probability says we should get one more, and then we should probably get a 6. That's higher, so the probability is working out pretty good. So the probability says now, after 9 of these, we probably will get one that is a 6. It doesn't mean we definitely will, but we probably will. Either way, it's going to be really close. Here we go. And it's higher. So it's not exact, but 70% of the time, this was higher. And 30% of the time, and I know that because it's 7/10 and 3/10, 30% of the time it was lower, which is really close to what the prediction would say. So my challenge to you is to take a close look at this chart and see if you can go back and recreate it. Pick a card, any card, test it 10 times, and see if the reality matches the probability. And the reason we care is that it's a really neat way for you to test, like when you play this game, what makes the most sense to do. You've all already identified that 8 is by far the worst card to have, and that's because you have an equal chance of it being higher or lower. And in both cases, it's less than 50%, so it's not a good bet. And 8% of the time, you're going to pick the same card anyway. So 8 is like the last card you ever want to have. So anyway, give it a try, see how it works out. If you can try for all of them, that's awesome. If you feel really ambitious and you want to try it 100 times, go crazy and see how it works. If you do that, you might want to take the cards, put them back in, and reshuffle every time. So have some fun with that, and let me know how it goes.